Hello and welcome to Dan Explains. The idea of alien pathogens wreaking havoc is a very popular plot device in sci-fi movies, TV series, and books. In fact, one of the oldest sci-fi stories that eventually made it into a movie, War of the Worlds, used an infectious Earth pathogen as a plot device to kill off the invading Martians when the Earth's defeat seemed certain. Could that actually happen? Or, even worse, an asteroid or aliens bring some kind of deadly alien pathogen to Earth? Maybe. Let me explain why. Here on Earth, the spread of alien pathogens has been a big issue since the age of exploration began over 500 years ago. And by alien, I don't mean outer space alien pathogens, but just pathogens that are alien to the new regions that they suddenly found themselves in. Although the age of exploration is pretty much over here on Earth, there are still uncontacted tribes out there we have to be very careful with because of this issue. It's not only a problem with humans either. Dutch elm disease and chestnut blight, which pretty much wiped out the American chestnut reproductively speaking, are two brilliant examples in plants. Growing up as a kid, I was a real space nerd, but I didn't know much about biology beyond watching those documentaries on PBS about life of the white-tailed deer. So when I heard about how Native Americans nearly got wiped out by European pathogens when the Europeans arrived, I thought the same might happen to us if we ever traveled into space and found alien life, even if it was just microbial life. Then I got a degree in molecular biology, and I had to readjust my opinion on the subject. And oh, a side note, the Europeans did also bring back pathogens from the Americas, the most famous one being syphilis. Like I pointed in my intro, aliens, and this time by alien, I do mean space aliens. Anyway, alien pathogens have been a very popular idea in a lot of sci-fi stories. Because we literally have zero information about alien life, there is a wide range of possibilities. The first deciding factor is whether we're talking about life with the same origin as ours, or completely separate trees of life with different origins. If panspermia doesn't happen at all, or is really unlikely, which is the idea that life spread across space as microbes on asteroids and comets, then most or all of life in the universe won't be related in any way. If that's the case, alien pathogens would probably not even be able to infect Earth organisms. First off is the chirality problem that never seems to come up in sci-fi. You see, many molecules have a handedness like humans do, but left-handed versions of everything that makes our life up could exist. For the most part, we can't process or digest left-handed molecules. This is why artificial trans fats are so bad, because it's made in a non-selective industrial process that makes a mix of left and right-handed fats. And left-handed fats don't get digested completely. A human trying to eat food from an alien with a left-handed chirality would be an extremely bad idea. An Amazon river's worth of Pepto-Bismol wouldn't fix the indigestion from that meal. So, if for many separate life origins, then you expect 50% of molecular chirality of alien life to be right-handed and 50% to be left-handed by random chance. To pathogens with left-handed chirality, our bodies would be like a food desert. Left-handed viruses in the right-handed world would get it the worst, and vice versa, since they hijack the molecular machinery inside of the cell to replicate. Not only would they not be able to get into the right-handed cells, but even if they did, they couldn't use the cell's machinery to replicate. So that knocks out 50% of possible alien life right there. Now, what about the other 50%? Well, for life of another origin, it would take a miracle of convergent evolution for there to be too much of an issue. Again, viruses would be a non-starter, similar to that of the chirality issue. If they use different amino acids or peptides, the molecular machinery would be incompatible. Also, the spike proteins used for binding to the target cell would most likely be totally different, making getting into the cell impossible. Alien bacteria may have it a little better, since they would most likely use the same set of molecules as our life does, assuming it's water-based life and not ammonia-based life anyway. They would probably be quickly detected by our immune system, however, because their surface proteins would be so different. The one side case here is if the proteins found on their cell surfaces are so different, our immune system can't form antibodies to the alien bacteria. So, if panspermia is uncommon, then alien pathogens being any kind of threat to us is extremely remote. If panspermia is common, then things become more complicated. There is an idea that I've mentioned in my channel before, proposed by Harvard professor Abby Loeb, that all life has a common origin, a few 100 million years after the Big Bang, when the universe was much smaller and the cosmic background radiation was room temperature. Then, all life would be related. But just how related would depend on how advanced it got before that warm era of the universe ended and all life got separated and isolated on different rocks. Right now, it's thought that our life started by using RNA as its genetic store of information rather than DNA, since many of the enzymes of the earliest origins incorporated a lot of RNA into them. So RNA can store information like DNA, but also be used like a tool like peptides that make up proteins. If the era ended before peptides and DNA came about, it would probably be very much like having a separate origin. But unlike that scenario, all life would have the same right-handed chirality that we do. The situation would be much closer to alien life depicted in sci-fi. But dangerous alien pathogens would be unlikely. If life did get to the point of having DNA, that starts to bring up the risk factors. But not as much as you think. If alien life ever made it to multicellularity before the end of the warm period, which is one evolutionary step we know for sure didn't happen until long after life was on Earth, so aliens are probably much different than us on a cellular level. Bacterial infections could still be a threat, but in that case, due to the close relation to our bacteria, then antibiotics would probably still work on. When it comes to viruses that infect multicellular organisms like us, odds are the surface proteins would be too different to infect our cells. You'll notice the animal viruses that the experts are usually worried about jumping into humans mostly come from organisms like mammals, birds, and reptiles, not things like fish, octopus, and insects. The reason for this is because mammals, birds, and reptiles are all fairly closely related to us compared to the other organisms. Viruses that are adapted to infect organisms that branch off our tree of life while life was still single-cellular would be even more different than the viruses of fish, octopus, and insects. Basically, the threat is really low. This also applies for the special case of Mars. You might think that since Mars is so close to us, it would be also a lot easier for panspermia to do its work, so if there was life, it would be more like us. It's true that if life were on Mars, that it would most likely be fairly closely related to ours. However, multicellular organisms don't do well in space. Even the hardy tardigrade probably wouldn't survive the several thousand-year journey followed by re-entry of Earth's atmosphere. Even if that could happen, which it couldn't because Mars was also a cold dead husk of a planet by the time multicellular life ever arose, so then it would fall into the too distantly related group that I already mentioned. So how likely is it for some alien pathogen to infect us if we finally meet aliens? Not that likely, even if they were Martians. So you can go to bed easy tonight without having to worry about some space rock hitting your house and delivering some alien plague that's going to wipe out humanity. And, oh, but what about alien parasites? Well, that's a story for another video. Thank you for watching. If you like this video, please press the like button, subscribe to my channel, and ding the bell to get notified when I post new videos. Also, please support me on Patreon, link in the description. The more people who support me, the more time I can dedicate to making videos like this one. So, until next time, have a great week.